We are Project Team 9, and we are compared gas metal arc welding with laser arc hybrid welding. Gas metal arc welding is a welding process where an electric arc is formed between a metal workpiece and a continuously fed wire electrode. This arc generates heat that melts both the wire and the base metal, allowing them to fuse together and form a strong permanent bond. What makes this process especially effective is the use of a shielding gas, which flows through the welding gun along with the wire. This gas shields the molten weld pool from containments in the air, ensuring a cleaner, stronger weld. Gas metal arc welding is a semi-automatic process. While the wire feed and arc length are handled by the machine, the welder controls the travel speed and positioning manually. This combination of automation and manual control makes it both efficient and flexible. Importantly, gas metal arc welding works well with a wide variety of metals, including steel, aluminum, and other non-ferrous materials. Whether you're welding thick structural steel or thin automotive panels, gas metal arc welding can do the job. The advantages of gas metal arc welding is first, it's easy to learn. Compared to other welding techniques, gas metal arc welding is beginner friendly and can be operated with one hand, making it accessible for new welders and great for training. It is very versatile. Thanks to the variety of fillet or wire options and compatibility with different metals and alloys, it can be used across many applications from automotive repairs to aerospace manufacturing. Third, it produces less mess. The shielding gas significantly reduces splatter and slag, meaning less cleanup and smoother weld finishes. It offers very precise control. Gas metal arc welding machines let users adjust settings like wire feed speed, polarity, and amperage to suit specific jobs, giving welders more accuracy and customization. Last, it's very efficient. The semi-automated process and one-hand operation improve welding speed, reduce fatigue, and make the process easier overall. Because of these benefits, gas metal arc welding is widely used in industries like construction, automotive manufacturing, and even shipbuilding. Some of the other uses which it's used in is aerospace and manufacturing. Some of the disadvantages of gas metal arc welding include cost. The initial investment in a gas metal arc welding machine is relatively high, and like any piece of equipment, it requires regular maintenance and occasional part replacements. Users need to purchase the wire as well as the shielding gas. Second, it's not ideal for outdoor use. Wind can easily blow away the shielding gas, which compromises the quality of the weld. That's why gas metal arc welding is primarily used indoors in controlled environments. Third, there's a risk of burn through when working with very thin metals. Anything less than half a millimeter thick can be tricky to weld without damaging the metal. And lastly, gas metal arc welding has limited welding positions. The high heat and fluid nature of the weld puddle make it difficult to perform overhead or vertical welds, especially with spray transfer mode. Gas metal arc welding also poses the problems of portability. This machine shown here in the picture is a very large machine, which is the machine for gas metal arc welding. Because this machine is so large, it makes it hard to transport.
Now we can look at the cost of gas metal arc welding. Typically, this is the least expensive for all welds that can be used for many applications. Semi-automatic is much more expensive than fully automatic for gas metal arc welding. Automatic gas metal arc welding operations will give higher deposition rates and operating factors. The cost of electrode wire and shielding gases can vary widely because of price differences between different types and sizes of electrodes and different types of shielding gas. The cost of electric power consumed will depend on the type of machine, amount of welding, and the welding currents being used. The first cost we can look at is labor and overhead costs. Operator factors for semi-automatic welding usually range from about 25% to as high as 60%. Deposition rates and travel speeds affect this labor head labor and overhead costs greatly. This affects productivity, which affects how long the labor takes. This is affected by the size of the electrode wire, the welding current, the thickness of the base metal, and the type of base metal. In the top right, we can see the cost equation for labor cost and the labor and overhead cost per hour times the pounds of weld deposit over the foot of weld, all over the deposition rate times the operating factor. Under that, we can multiply the total welding time by the labor and overhead costs per hour to get the total cost. The second cost we encounter is the cost of the electrode. This is determined by the weight of the weld deposited, the cost per pound of the filler metal, and the deposition efficiency of the filler metal. The small diameter solid electrode wires used for this process cost more per pound than larger diameter solid electrode wires and covered electrodes. Electrode wire is less expensive per pound when supplied in a reel or large coil as compared to a small coil. The total amount of wire purchased also affects the cost. Large shipments of wire will generally cost less per pound than small shipments. In short, the bigger and heavier the wire is, the less it will cost per pound. On the right, we can look at the electrode cost per foot of weld when we multiply the arc time times the wire feed rate times the wire rate per unit length times the wire cost per pound. Then we can find the electrode cost per foot of weld when we multiply the weight deposit times filler metal costs over the deposition efficiency. The third cost we have is the shielding gas. We can see on the right that the shielding gas equation is found by multiplying the arc time times the gas flow rate times the cost of the gas per cubic foot, which is dependent on what gas we use. The final and fourth cost that we encounter is the electric power. The electric power cost is found multiplying the welding current times the welding voltage over the power source efficiency, multiplied by the arc time, multiplied by the power cost per kilowatt hours. In this cost example, we can take a look at the differences between semi-automatic, automatic gas metal arc welding. Looking in the final row, we can see that the total cost is almost 3 times more for the semi-automatic versus the automatic gas metal arc welding. This shows how the automatic gas metal arc welding is a lot cheaper. Now we can look at the process of laser arc hybrid welding. The laser beam and the electric arc in this interact in a common weld pool, and their synergetic effect is utilized to produce a deep and narrow weld with increased production rate. This approach uses a head that carries both the laser focusing optics and the gas metal arc welding gun. The laser beam creates a keyhole near the leading edge of this puddle. The motivation for this concept is that the best features of each process can be combined to create an even better process for certain applications. Laser beam welding provides the capability for deep penetrating single pass welds at high speeds, but requires precise joint fit up and doesn't produce weld reinforcement, which can add strength to the joint. When combined with gas metal arc welding, these limitations are eliminated. The laser beam also helps to stabilize the arc, which can be in particular benefit when welding titanium. This gained popularity when people realized this is much better than laser welding on its own. It has reduction in volume fraction of brittle phases, cracks, and thermal distortion when compared to single arc welding or laser welds. In addition, using laser arc hybrid welding allows to bridge excessive gaps between the workpieces to be welded, which is not allowed during conventional laser welding. Finally, the dual use of laser and arc as the heat source allows to achieve significantly higher welding speeds, while the penetration depth also increases, translating to overall higher productivity.
So what are the advantages of hybrid laser arc welding? To begin, the welding efficiency and speed are greatly increased. A continuous welding process, the time required to complete welds decreases, since the quickness and precision reduces the time for a production cycle. The quality and stability of the welds also improves. The low heat affected zone reduces the chances of deformations, such as cracks and warping, and the precise control of the laser allows for a more stable process and product. In addition, the heat input is decreased. This is beneficial because, like I mentioned previously, it reduces the possibility of material deformation and distortion. There's also less penetration, which is ideal for heat-sensitive materials. The depth of the welds can be much greater with this welding style, meaning they can be used indoors or outdoors on tougher materials. This leads to versatile applications, such as shipbuilding and more, discussed later. Some materials this is beneficial for include high-strength steels and aluminum alloys. However, there are some disadvantages. For one, the material and surface requirements of the workpieces are high. They must be completely free of contaminants, especially when metals are prone to oxidation and rusting. In this case, the welding quality and strength can be affected. The equipment costs, as well as other direct costs, are much greater than that compared to gas metal arc welding, shown in the next slide. There are also much higher technical requirements to learn and operate the machinery of hybrid laser arc welding. As I mentioned previously, the cost can be a drawback for hybrid laser arc welding. Equipment is not cheap, and laser systems, and especially laser arc welding systems, are very expensive. This includes the laser source and specialized equipment to handle the conditions of such a process. As for the service costs, operation of the equipment requires knowledgeable and skilled technicians and welders. They must set up, operate, maintain, and repair these complex and potentially dangerous systems. On the other hand, if a company would want to train in-house welders in this process, the cost of this training would be great. It would still require skills and expertise from outside third parties, but now the initial cost would hopefully be outweighed by the long-term gain of having this knowledge easily accessible.
Okay, so there are a few different applications of hybrid laser arc welding. One of them is the automotive industry, where this method is used on different parts, such as the body structures and the chassis. And this process is also used in the shipbuilding industry as well as the aerospace industry. And the common theme between all of these different industries and applications is the fact that hybrid laser arc welding is typically used on structural components. And the reason for that is that these components not only need to be held to a high level of strength, but they also need to be very precise. And that's where this method of welding tends to do best. So comparing gas metal arc welding to hybrid laser arc welding, we can see that there are several differences between the two. So first of all, the process itself in gas metal arc welding, there's a continuous wire feed, and then an arc between that wire and the base metal is what creates the weld. Whereas in laser arc welding, the laser beam is used with an arc to produce that weld. And through these processes, with the gas metal arc welding, there's a high level of heat required to create the weld itself, which in laser arc welding, you don't need as much heat. And as a result, it creates a smaller heat affected zone in the metal. With the gas metal arc welding, we see a slower speed of welding compared to laser arc welding. And part of the reason that the laser arc welding can have a higher welding speed is because it can be automated. However, that automation does come with a higher cost in the laser arc welding compared to gas metal arc welding, which the equipment is a lot cheaper relatively. And overall, the gas metal arc welding is good for just general use, whereas the laser arc welding has only been used in certain applications, like I mentioned before. And part of the reason for that is that it's difficult to do. It's expensive, like I mentioned. It's difficult to learn how to do it, and the process is more complex than gas metal arc welding, which is why it's only used in specific applications. Whereas the gas metal arc welding is easier to learn. It's easy to train operators to perform this type of weld. And so that makes it better for an overall general use. So taking everything into consideration, when we evaluated the manufacturing readiness of the laser arc welding, we decided that a rating of 8 was appropriate for this manufacturing process. And the reasons for that were the system, first of all, is commercially available already. Like I mentioned, it's been used in a few different applications. And in those industries, we have seen how it can be effective. So it has been used in low production atmospheres, such as cars and airplanes, and it has been successful so far in those uses. And through those different industries, people have a good understanding of how much that costs to produce, and how much it costs to operate hybrid laser arc welding. And so we have a pretty good model of those costs. Now, the reason it didn't receive a high rating is, first of all, because it hasn't been used in many applications outside of the ones listed. And so in order to give it a higher rating, it would really need to be applied to broader contexts, and it would need to be proved to be effective in industries besides the ones I listed and for structural components. Additionally, the components in the places that it's used tend to be at a lower rate of production. And so we would want to see it be applied to areas where there's a higher rate of production to ensure that the process is still controlled and consistent. And in this case, we could then maybe increase the rating to a higher level.